iron, almost plastic in the white heat of the fire, forged together under the blows of the blacksmith's hammer. It's an age-old process, but with the hammer replaced by continuous mechanical pressure and the forge by electrical heat, it is still used by today's sophisticated resistance welding machines. Resistance is a term describing how heat is generated by restricting the flow of an electrical current. For example, along this heavy section cable with low resistance, current flows easily. But by reducing its thickness, resistance is increased, and as the flow of current becomes more restricted, more and more heat is generated until the cable melts. As the electrical resistance of different metals vary considerably, they can be chosen to produce high resistance and heat where required. For instance, current flows easily through the aluminium or copper wires of a flex, but meets high resistance in the thin nickel-chrome element of the fire. High resistance also occurs at junctions. When two rods are pressed together and a current passed through them, the ends melt at the junction and weld under pressure. This is a resistance butt weld and one of 5 resistance welding processes in everyday use. The most common use of resistance welding is for spot welds. The spot welding machine is designed to carry a high current, low voltage supply to a pair of copper bar electrodes. The tips are tapered or domed to increase the resistance and concentrate the heat into a small area. The face diameter of the electrode tip must be correct for the job in hand. Progressive wear increases the face diameter, causing loss of current concentration and effective weld heat. Now, watch this. Simple, isn't it? Let's take a closer look at what happens. 2 thin sheets of mild steel are placed between the electrodes and pressure applied. The welding current is switched on and it flows easily through one copper electrode into the first steel sheet. But here it meets high resistance because steel is a poor conductor of current and heat, and there is a junction between the sheets. The current then flows easily out through the second electrode. In the confined area of high resistance at the interface, heat is generated which raises the steel to its plastic temperature. The current is switched off, but the pressure is maintained while the metal cools to form a weld nugget which joins the sheets together with a strength equal to the parent metals. A good weld depends on 3 basic factors: current, pressure, and time. Their effects are interrelated, and the ideal combination will vary to suit the component material and thicknesses. High currents are needed for all resistance welding techniques, though only for short periods, and peak currents of 500 to 200,000 amperes may be necessary, but the voltages used are low and are between 1 and 20 volts. A transformer gives us the correct welding current. The normal mains supplies high voltages of 415 or 240 volts at low amperage. This is converted by the welding transformer into the high amperage and low voltage required. And by varying the effective turns on the primary side of the transformer, a range of currents can be delivered. Most welding machines use 2 phases of the 3-phase AC supply. Some special machines use all 3 phases, which are then rectified either before or after the transformer to provide direct current for welding. Pressure, or electrode force, can be applied in several ways. Here, it's applied by the operator, who uses a foot pedal with a linkage mechanism. But sustained high production is best served either by air cylinder pressure, which is easily controlled by electrically operated valves, or by hydraulic cylinder, which gives the highest pressures and is used principally for multi-spot welding machines, where many cylinders have to be grouped in a small area. Correct pressure or electrode force is essential. Too little allows the molten metal to escape, causing surface burning and other defects. When the weld is opened up, the splash of exuded metal is clearly seen. Too much lowers resistance and heat at the junction. This causes deep surface indentation, compressing the metal walls surrounding the weld nugget and weakening the joint. Indentation should not exceed 10% of the sheet thickness. The third basic factor, timing, is of critical importance, especially when welding light thicknesses of steel, high conductivity metals like aluminium and copper alloys, and materials with a very limited plastic temperature range. Let's look at the 3 stages of timing. First, there's the squeeze time, which elapses before the current is switched on. Then the weld time, during which the current flows and the joint heats up. And lastly, the hold time, in which pressure is maintained while the weld cools. This is an ideal spot weld nugget. Its strength is equal to that of the parent metals. A small weld nugget lacks strength and can be caused by too short a weld time, incorrect pressure, or an oxide film on the surfaces which can hinder the current flow. A small nugget can also be caused by the close proximity of a previous weld, which causes shunting. Most of the current chooses the easiest path and bypasses high resistance at the junction. An oversized weld nugget also lacks strength and can be caused by too much current, too much time, or too little pressure, which allows the molten metal to exude, resulting in a splash weld with cavities in the nugget and possible separation of the sheets. Throughout industry, resistance spot welding is used to join a wide range of metals. Because weld times are short, high output is possible. Because only a small area is heated, distortion is negligible and no finishing treatment is needed. And because the method is faster and more reliable, it's replacing soldering for joints on miniature components. Portable equipment allows large, heavy fabrications to be assembled in one shop, dispensing with complex jigs and mechanical handling devices. Spot welding is only one of several resistance welding processes. How the basic principles have been adapted and developed is explained in the next film of the series.